Engineers are renowned for pushing the limits of scientific discovery and research and guiding humanity toward lofty goals. However, they occasionally make grave mistakes, demonstrating that they are simply human like the rest of us. Engineering errors, however, are nothing like those that arise at work every day. From nuclear reaction explosions to the sinking of large ships to the explosions of space exploring rockets, when they go wrong horribly. Although we can undoubtedly learn from our mistakes and improve, some of the oversights, missteps, and gaffes on this list have had negative, long-lasting impacts. Number 5. Chernobyl. Most people have heard of the worst nuclear disaster in human history, which is only surpassed in size by the Fukushima reactor accident. More on that later. At the Chernobyl nuclear power plant, a fundamentally defective reactor detonated on April 26, 1986. The incident that destroyed Unit 4 occurred during a maintenance shutdown, making it the ideal time to test whether, in the event of a power outage, the turbine would continue to supply energy to the system to power the cooling water pumps until the emergency power supply was operational. Unfortunately, not enough safety measures were taken during the test, which was intended to increase the plant's non-nuclear operational capacity. Due to improper communication and coordination between the people conducting the test and the staff in charge of the reactor's safety, operational failures triggered the potentially catastrophic disaster circumstances that were already in place. Radiation was massively released into the atmosphere as a disastrous outcome, covering a sizable portion of the Western Soviet Union and Eastern Europe. 350,400 individuals were relocated and forced to leave the most contaminated areas of Belarus, Ukraine, and Russia during the ensuing evacuation. Number 4. Bhopal. A poisonous gas leak occurred in 1984 at a Union Carbide pesticide manufacturing facility in Bhopal, India. According to reports, what is regarded as the biggest industrial tragedy in history was ultimately caused by a multitude of substandard circumstances, persistent violations of safety laws, management carelessness, and general disrespect for safety. The exothermic reaction that was set off when water somehow entered a methyl isocyanate (MiC) tank was severely aggravated by several factors, including iron from corroding steel pipes. 2 independent staff members believed that the reading gadget was malfunctioning even though the pressure in the tank increased in just 30 minutes. The personnel began to experience the symptoms of MiC gas exposure after 30 minutes, and efforts were undertaken to locate the leak. Despite the leak being found, it was decided to address the situation following the tea break. By the time a tea break was over, the tank's condition had deteriorated to the point of criticality, and the emergency relief valve had ruptured, spilling poisonous NiC gas into the atmosphere. 2 of the 3 safety measures put in place to prevent the atmospheric release of the lethal gas were also either the wrong size, broke down, or were otherwise non-operational. There were 2,259 fatalities right away and 11,000 deaths overall. Even now, 25 years after the incident, the area around Bhopal is still dangerous for both humans and animals. Number 3. Titanic. The Titanic, which had a length of more than 800 feet and a weight of 46,000 tons, was the largest ship ever constructed in 1912. The various reasons that contributed to the ship's quick demise after colliding with a massive iceberg while it was traveling at its top speed, 22 knots. Even though its design was successful in impressing the general public aesthetically, became the subject of scrutiny and examination for many engineering researchers. The material failures and defects in the ship's design have caused researchers to surmise that safety was probably not the main priority when it was being built. For instance, to provide first-class passengers more room and a better view, 1 row of safety boats was eliminated from the original design. The effects of the structural modifications were felt by more than half of the 2,200 passengers on board the Titanic. After the crash, the ship made its way to the bottom of the Atlantic Ocean in just 180 minutes. Because the height of the bulkheads was reduced to better fit the first-class public areas, 5 of the watertight compartments flooded, which was a serious failure. The high sulfate content in the steel and the cold water, which severely reduced the hull's steel and rivets capacity to contain flooding and hastened the sinking, are further explanations cited by researchers as contributing to this collapse. As a precaution, all these factors are now taken into account when building huge ships, and numerous safety rules have subsequently been implemented to ensure that similar catastrophes never occur again. Number 2. Challenger Space Shuttle. On January 28, 1986, 73 seconds after launch, the Challenger Space Shuttle disintegrated in a catastrophic explosion that killed all 7 of its crew members. Ronald Reagan, who was the President of the United States at the time, created the Rogers Commission to look into the incident. Even though the accident's primary cause was known only a few days after it occurred, it took only a few weeks for the cause to be fully identified. Two rubber O-rings had suffered greatly due to the recent extreme cold wave that had swept through central Florida. The right-hand rocket booster's two-segments joint was sealed by these O-rings. A member of the Rogers Commission demonstrated the drop in resilience by immersing an O-ring in a glass of icy water during a commission session. The Marshall Space Flight Center in Huntsville, Alabama, and Morton Thiokol, incorporated in Ogden, Utah in particular, were publicly criticized by the Rogers Commission for their poor engineering and administration in a report that was given to the president. Although only a contractor, Morton Thiokol was in command of the booster motors even though they were put together at the Kennedy Space Center at Cape Canaveral, Florida. The Marshall Space Flight Center was responsible for the shuttle boosters, engines, and tanks. The Rogers Commission was able to compile unsettling testimony from numerous engineers who had been vocal about their worries about the seal's dependability for at least 2 years and who had warned their bosses about the risk of a failure just the night before the launch. NASA decided to add several checkpoints in the administration of the space shuttle as a result of the disaster and subsequent doubts about its quality and safety control measures, including a new NASA safety office and a shuttle safety advisory panel, to prevent such an erroneous choice as launching that day from being made again. Number 1. Cleveland, East Ohio explosion of gas. On October 20, 1944, in the late afternoon, this catastrophe took place. The explosion and ensuing fires claimed the lives of 130 individuals. On the east side of Cleveland, Ohio, a region of about 1 square mile was also damaged. This occurred when a vapor began to leak from a faulty well bead on the side of the poorly constructed surface tank number 4, which housed liquefied natural gas, LNG, in the tank farm of the East Ohio Gas Company. The gas spilled and mixed with air and gas from the sewage system, causing an explosion once it ignited. A second above-ground tank exploded 30 minutes later, destroying the remainder of the tank farm. Manhole covers erupted upward with subsurface fireballs, destroying countless homes and businesses in their path. Clevelanders could see the fireball from at least 7 miles away, and they could see the smoke even further out. According to calculations, the explosion had a temperature of almost 3,000 degrees Fahrenheit and was equivalent to a 2.43 K explosion of TNT. The natural gas sector saw significant upheaval as a result of the tragedy. Surface natural gas tanks were commonly used before the accident, and their presence in supply facilities for homes, offices, and industry was a common sight in cities across all of America. Underground natural gas storage soon became the new norm as utility companies and towns began to doubt the security of their natural gas storage systems in the wake of the catastrophe. So this is the end of our today's video. Do you like it? Kindly give your valuable response in our comment section below, and don't forget to subscribe to our YouTube channel for more interesting and informative videos.